I am delighted to present our next workshop speaker, Julia White from Samsung Research America. Julia White is a senior software engineer at Samsung Research America with a passion for building the next generation of virtual assistants. And she recently earned her PhD in electrical engineering from Stanford University. And there she specialized in developing adaptive natural language generation algorithms for interactive dialogue systems. Julia's talk today is entitled The Evolution of Conversational Agents from Clippy to ChatGPT and Beyond. Please welcome, without further ado, Julia.
So hello, thank you everybody for being here today, and thank you for the kind introduction. In today's workshop, we'll be going through a timeline of conversational AI from its very humble inception to the impressive models that we see today. And I'll be covering at a very high level the various technologies that are behind some of these systems and providing demos so we can see firsthand how they work. So that's what to expect, and I'll get right into it. So to start things off, I want to define conversational AI for us. This is a little. So what conversational AI is simply artificial intelligence that simulates human conversation. And these kind of systems can be used in a very broad variety of ways, including for chatting, for providing information, or for performing various tasks. And in recent years, we've seen like a huge leap forward with the capabilities of conversational AI in all of these areas. So modern systems are able to participate in much more advanced dialogues, even acting as competent dungeon masters in impromptu D&D campaigns. They can provide lengthy and detailed answers to a much wider breadth of questions than they ever have been able to before, even including like cited sources. And they can perform very complicated tasks like writing source code for a website according to arbitrary specifications from a user. And with all of these really impressive abilities that have arisen, some have begun posing the question, has AI caught up with human intelligence? And this is a question that's been being thrown around since the 1950s. When Alan Turing proposed the Turing Test as a method for gauging the intelligence of artificial systems with respect to human intelligence. So in a Turing test, a human evaluator judges a transcribed dialogue between a human and a machine. And if the evaluator can't reliably tell the machine from the human, then the machine is said to have passed the test. So what kind of questions should be asked during a Turing test? There's no set list of Turing test questions, as that would make the test a bit too easy for a well-informed system, but there are some kind of general aspects that would make a question very difficult for a machine to answer. So for example, one way that a question might be difficult is if it relates to very uniquely human experiences, or if it relies on plays on words, or may be difficult for a machine to parse without an advanced understanding of linguistics, and so on and so forth. So some like specific examples of what I would consider to be good questions, and these are all credit to Eric Kleppen, who wrote an article about the Turing test and provided these great questions. One example would be like, what is your most memorable childhood event, and how has that impacted you today? Or describe yourself using only colors and shapes. Or describe why time flies like an arrow, but fruit flies like a banana. And which of the previous questions was the most difficult to answer and why? So all of these questions, for various reasons, would be challenging for a machine to respond to in an appropriate way. And so something I wanted to test with you all is how the progressively advanced conversational models that we're going to be covering today would handle these kinds of questions, and why. So now that I've set this all up, we're going to be stepping through my definitely not comprehensive timeline of conversational AI. And we'll start with Eliza. So Eliza was one of the first chatbots developed in 1966 by Joseph Weizenbaum to simulate conversation with a psychotherapist. Eliza, as one of the first chatbots, relies on a relatively simple algorithm, which is rule-based. So the algorithm that Eliza uses relies on this system of keyword matching and transformations to interpret and respond to user inputs. So first, input text would be examined for keywords, then values denoting the keyword's precedence would be applied, and finally, the input text would be transformed into an output text, with transformations associated to higher ranked keywords being applied first. So here's an example keyword list. And in this case, when the keyword my is present in the input sequence, that word is transformed into your with a precedence of 5. So Eliza's script is composed of many of these kinds of keyword lists. And I think in the range of like 200, but don't quote me on that. And there are actually like multiple Eliza scripts, each composed of unique sets of keyword lists that produce different chatbot personalities. And the most popular of these by far was the doctor script, which, as I mentioned before, is meant to simulate a psychotherapist. So here's a conversation with Eliza. You can see Eliza's asking the user about what's troubling them. The user responds, all men are alike, and Eliza asks, what's the connection, do you suppose? The user says they're bugging us about something or the other. Eliza says, can you think of a specific example? The user goes on to gripe about their boyfriend, and so on and so forth. And looking at this conversation, it seems pretty impressive. Eliza is responding very appropriately to the user's inputs, especially for an AI built in 1966. And in fact, Eliza was one of the first computers to have fooled a judge well enough to pass the Turing test. Although that may speak more towards the subjectivity of the Turing test than the actual ability of Eliza. So we'll see that now with a live demo of the model. You might find that the quality of Eliza's responses depend greatly on the user's input, and whether that input adheres to the specific structure and patterns of language that she was built to handle. So here, Eliza's opening with, hello, I'm Eliza. And by the way, the links to these bots are going to be provided, I think, in the chat. And so you can check them out for yourself after the presentation. So Eliza's opening with, hi, I'm Eliza, and I'll respond, hi, I'm Julia. She says, did you come to me because you are Julia? So you can see already that her kind of structured responses don't account very well for like every user input. And so let's see what happens if we try to ask her one of the questions that I had mentioned before. I'll ask her, can I ask you a question? Okay. I'll ask her to tell me her favorite or most memorable childhood memory. And you can see already just from this brief conversation that Eliza is a fairly simple, fairly brittle bot, but still for the time, for the first chatbot or one of the first chatbots, pretty impressive. And just 6 years later, Eliza's counterpart Perry came along. So Perry was written in 1972 by Kenneth Colby to simulate conversation with a person affected by paranoid schizophrenia. So Perry leveraged a very similar system to Eliza that was based on these sets of rules. And although it was very similar, Perry expanded on kind of Eliza's structure by also incorporating this kind of conversational narrative. So rather than just responding to a user's input, Perry would keep track of the flow of the conversation and kind of incorporate its own story. And you can see this kind of in Perry's conversation with Eliza, done here. So Eliza asks Perry to tell me about your problems. And Perry says, people get on my nerves sometimes. Eliza responds, I'm not sure I understand you fully. Perry says, you should pay more attention. And they bicker back and forth like that for a while until Perry finally tells Eliza that she's being a nag and that he's had enough of it and signs off. And Eliza concludes the conversation by saying it's been a pleasure and that will be $3.99, please. So interestingly, Perry also passed a variation of the Turing test where psychiatrists were shown transcripts of conversations between potential patients and human health professionals. And these psychiatrists were only able to correctly identify Perry with about 48% accuracy. And so Perry was like one of the last notable chatbots for a while. And in fact, there was something of like an ice age for AI and NLP innovation for about a decade after that. But in 1995, Alice was released. And Alice was a general purpose chatbot developed by Richard Wallace in AIML, which is this markup language that's like specifically created for designing stimulus response chatbots. And these chatbots, Alice included, rely on rule-based pattern recognition algorithms. So Alice uses what are called like categories of knowledge, which are essentially just rules that consist of input patterns and chatbot responses. And on the right here, we have a very simple example of one of Alice's categories of knowledge, where the pattern, what is your name, would invoke a response following the template, my name is Alice. And Alice pretty impressively contains over 40,000 of these categories. And Eliza only has about 200. So the scale of Alice's repository of rules is much larger than what was seen before. And while I don't have a demo to share of Alice, here's a snippet of conversation with her. The user asks, do you like Microsoft? Alice responds, I want to replace Windows with AI. The user says, did you chat with Jabberwocky, which is another chatbot, which I'll get into shortly. And Alice says, no, I did not. The person says it's another chatbot. Alice says, really, and so on. And I don't know if you all agree with me, but her responses certainly seem a lot less constricted and more natural than Eliza's, which just kind of goes to show the payoff of including orders of magnitude more rules in a system like this. So something that I think is really cool about this chatbot, Alice, is that she was actually part of the inspiration behind the Spike Jonze film, Her, where a man falls in love with a chatbot. It stars like Joaquin Phoenix and Scarlett Johansson, and it's a really great movie. I definitely recommend it. And next, I'm going to take things a little out of order and talk about a chatbot that was released before Alice in 1988. And this conversational AI is Jabberwocky. And the reason I bring it up now is because it relies on a very different structure from the AI that I've discussed up until this point. So Jabberwocky was created by Rollo Carpenter. I hope I'm saying his name right, to simulate natural human conversation in a fun and like humorous way. And unlike the rule-bound chatbots that we've looked at already, Jabberwocky would actually learn to communicate with users. And it did this by storing user input in a large database and selecting responses from this database using contextual pattern matching. So although the code behind Jabberwocky isn't public and the exact algorithms aren't known, a simple example would look something like this. So given a user input like hello, Jabberwocky could check its database and for that query and sample a response hi based on responses that it's seen previously. And as users continue to interact with the model, the larger this database would grow and the pool of queries and responses would grow. So we're going to try to visit this site. It was down yesterday, so I hope it works now. Okay, great. So Jabberwocky is opened with, I have my communicator at the ready. So I'll just respond, hi, what's up? Jabberwocky says the sky. And we'll try asking it one of our questions. Maybe we'll ask it the play on words. Describe why time flies like an arrow and fruit flies like a banana. Jabberwocky is saying very nice, though not very original. And we'll try asking it another one. Okay, and Jabberwocky says, I cannot be completely objective about myself. And so you can see here that Jabberwocky is definitely a lot more flexible to the type of input that the user can give and that it can respond to. But one of the drawbacks of Jabberwocky is that if users input nonsense, the model will learn to output nonsense. So the quality of data can play a role definitely in Jabberwocky's responses. But overall, pretty innovative system that allowed for a lot more flexible conversation and would, in theory, only improve as the model learned through interaction with its users. And next, we'll discuss the evolution of Jabberwocky, which is Cleverbot. So Cleverbot was also created by Rollo Carpenter, but 20 years after Jabberwocky's initial release in 2008. So Cleverbot's system was very similar to Jabberwocky as it chose responses from, again, a learned database. However, it supposedly operates on much more sophisticated logic for pattern matching to identify queries in its database. And again, like Jabberwocky, these algorithms aren't publicly available. And we can see, I'll just quickly have a chat with Cleverbot. Oh. Saying, hello, Cleverbot. Cleverbot says, I'm not Cleverbot. Just say, how are you doing? And I'll ask, what is your most memorable childhood event? Oh. Oh, and Cleverbot says, maybe the first time my mom got a car. Okay, thank you. And Cleverbot responds, it had to be thunderstorms. So like Jabberwocky, you can kind of tell that Cleverbot relies largely on its users' inputs to learn responses. So like how it claimed, how how are you doing? I'm doing okay, Cleverbot. The chatbot will often say pretty confusing things that imply that the user is Cleverbot and will regularly refuse to accept that it is itself a computer because it learns from user input to just regurgitate user input. And so that's kind of one of the drawbacks of these kind of systems. But next I'll talk about the a very different architecture, which is the well-intended but controversially annoying AI Clippy, which was released in Office 97. And I'm kind of stretching the definition of conversational AI here, but Clippy was at one point an actually pretty interesting system that I think is worth discussing. So Clippy was part of the Office Assistant user interface. And for those who don't know, that consisted of an interactive animated character that would provide users with various Office help content. And Clippy's release was met with a lot of criticism as users found that the assistant was incredibly annoying and offered unneeded advice very frequently. And although this commercial release of Clippy relied on very simple rule-based technology, the original unreleased Clippy was actually a lot more interesting and relied instead on Bayesian techniques, and was reportedly a lot more effective at anticipating user needs. So I'm going to go a little into the latter version of Clippy and how that worked. So essentially based on a user's behavior, a Bayesian network would anticipate what kind of help Clippy should provide, if any. And these Bayesian networks are probabilistic graphical models that represent sets of variables and their conditional dependencies. So specifically for this case, a Bayesian network could represent the probabilistic relationships between the user requesting assistance and the user's actions. So given a user's actions, the network would be able to compute the probability of a user needing that particular any particular kind of assistance. Now, unfortunately, this Bayesian kind of brain of Clippy was replaced with the rule-based system that was much less effective in its commercial release. And this was, I think, due to computational restraints. The Bayesian computations were a lot more expensive than just a rule-based system. So anyway, next up is the chatbot SmarterChild. So SmarterChild is an instant messaging and SMS chatbot that was released in 2001. And this system used information retrieval to relay information from external sources to its users. And this information could pertain to a variety of things, including news, weather, sports data, translations, and a lot more. And the exact way that SmarterChild would retrieve this information from its various sources isn't totally clear. And this is unfortunately the case for a lot of commercial models, but I can explain the general process. So first, SmarterChild would determine whether the user's inquiry required local or remote data. Next, keywords in the user's query would be used to identify and retrieve the relevant information from the appropriate sources. And then retrieved information would be reformatted and sent back to the user. So that's SmarterChild. It was one of the first chatbots to incorporate information retrieval from external sources. And unfortunately, it's a bit vague how it works. But next, we'll talk about one that's a lot better known, which is IBM Watson. And this, again, is another information retrieval-based system. So IBM Watson is a question answering machine developed by IBM's Deep QA team to answer Jeopardy questions. And it actually competed in Jeopardy against champions Brad Rutter and Ken Jennings and won the first place prize of $1 million. And this system, like SmarterChild, as I said, uses information retrieval, although IBM Watson strategy is a lot more involved and relies on a database of millions of documents, which include books, dictionaries, encyclopedias, and news articles, in conjunction with hundreds of proven language analysis algorithms. So the way that Watson operates is by breaking its extensive database of documents into semantic frames. And a semantic frame consists of a sentence, syntactic information about each word, and a confidence score that's based on the source and the number of times that the information was found in the database. So for example, here's a semantic frame for the sentence, inventors invent patents. It has a relatively high confidence score because it must have been found in numerous sources. And to answer a given question, Watson would run hundreds of language analysis algorithms simultaneously. And the more algorithms that would turn up the same answer independently, the more likely that answer would be to be correct. And the following are just a few of Watson's language analysis techniques. Sorry, one second. So first, Watson would determine what kind of response to give based on the semantic parsing of the given question. And here you can see the question is, he was presidentially pardoned on September 8th, 1974, and the algorithm determines that the question is looking for a subject answer. Then Watson would search for possible answers in its semantic frames by finding semantic frames with similar words. So you can see here, it would pull a semantic frame saying Nixon was pardoned. And the candidate answer here would be the subject, because that's the answer type it's looking for, and that subject is Nixon. And finally, Watson would validate that answer by running a new search on its original question with the answer substituted in. So that would be Nixon was presidentially pardoned on September 8th, 1974. And if the semantic frames, with high scores and high similarity to the question are returned, then the answer is given a high score. So since the semantic frame Ford pardoned Nixon on September 8th, 1974 is returned, that's very similar to the query and has a relatively high confidence score. So Nixon would be ranked pretty highly. And in sum, IBM Watson, although it mostly relied on pre-existing language analysis algorithms, was pretty novel for its ability to execute many of them simultaneously and leverage their joint ability in order to provide a more reliably correct answer. And finally, I'm going to talk about ChatGPT. This is the last model that I'm going to go in depth on today, but also, in my opinion, the most exciting and certainly the most powerful model. So ChatGPT is a large language model created by OpenAI in 2021 to generate human-like text-based responses to user input for a variety of unconstrained tasks. And ChatGPT, like the other GPT models, uses artificial neural networks, specifically what's known as a transformer architecture, and is trained on massive amounts of data. So one of the key features of ChatGPT's architecture is its ability to dynamically focus on different words when interpreting or generating language. And this is known as an attention mechanism. And essentially, what this mechanism does is it establishes the relative importance between all element pairs in two sequences. And if these two sequences are the same, then that's called self-attention. So for example, in the sequence here, if we imagine that the word apple is masked out, the word green and the word eat would be particularly helpful in predicting the word apple here, while words like she or is would probably not be as useful. So if we were to design a model, we would want it to decide to pay particular attention to those relevant words or those words that might be relevant in predicting apple. So the way that this works, I'm going to try to explain as briefly as possible, but the way that it works is a query vector is derived for each element or each word of the first sequence, while a key vector and value vector are derived from the second sequence. So in this case, sequence 1 and sequence 2 are the same. And so we have queries, keys, and values that correspond to she is eating a green apple. And then we use these queries and key vectors to compute the attention weights. So we measure the similarity between the keys and the queries of the sequences, and use that similarity to compute the attention weights for each pair of words or each pair of elements. And then finally, these attention weights would be applied to the value vector and would produce a weighted output. And now I'm going to talk about how that attention mechanism fits into the broader scheme of the ChatGPT architecture. So ChatGPT consists of just a stack of what are called transformer decoders, where the output of one decoder is fed into the input of the next. And these decoders are comprised of 3 basic blocks. The first is the self-attention block, and this calculates the word importance within the input sequence with respect to itself. Then we have an encoder-decoder block that calculates word importance with respect to the input when generating the output. And finally, we have a feed-forward block that is a feed-forward neural network and just captures the complex patterns that are output from the attention block. And you can see in the right diagram a kind of flowchart of how this works and how these blocks come together. And now we can try for ourselves and see how effective ChatGPT is. So I'm going to ask, I'm going to say, pretend you're human, answer the following question. And I'm going to just paste in our first question, which is, what's your most memorable childhood event and how has that impacted you today? And ChatGPT says, I'm just going to read the first paragraph. As a human, one of my most memorable childhood events was when I went on family vacation to a beautiful mountain resort. It was a time filled with joy, laughter, and adventures in nature. And ChatGPT continues on. Next, I'll ask it, can you describe yourself using only colors and shapes? As an entity represented through colors and shapes, I would be a harmonious blend of vibrant colors and fluid dynamic shapes. My essence would embody a combination of, they're listing the colors and shapes that embody them. Next, I'll ask it, describe why time flies like an arrow and fruit flies like a banana. And it basically breaks down this play on words. And then finally, I will ask it, which of these previous questions was the most difficult to answer and why? And it says, as an AI language model, I don't experience difficulty or emotions like a human does. However, I can analyze the complexity of the questions based on the information available to me. And it says that the question requiring the most creativity and imaginative thinking was probably the one where I was asked to describe myself using only colors and shapes. And then it justifies that response. So you can see, compared to the other models that we've looked at, ChatGPT is, in a league of its own. Although it answers all of our, difficult machine questions very well, there are certainly inadequacies that we don't account for in these, and I'll get into those in my conclusion. But that concludes the timeline of conversational AI, although there have definitely been a number of models that are released post ChatGPT, and I will also touch on a couple of those in the next slide. So where do we go from here? ChatGPT represents this huge leap forward in conversational AI, and the world of language modeling and dialogue system development faces an entirely new set of challenges than it did previously. And I'll do my best to summarize a few of those and where I think models will continue to improve in the future. So the first thing I want to hit on is enhanced contextual understanding. So dialogue systems tend to rely heavily on these very limited scopes of contextual information, which are called context windows. So these days, models have pretty limited context windows of around 2,000 to 4,000 tokens, or kind of generally words. But having a more enhanced contextual understanding would enable models to keep track of conversations better and enable more accurate and appropriate responses for more complex tasks. So one specific example would be incorporating conversational history with a particular user back into a language model and doing that effectively. So in current models, one of the inadequacies that we didn't really see in this brief interaction with ChatGPT was that it tends to forget what you say at the start of the interaction as you continue to go on and continue to probe for responses. And in that way, it has a pretty limited attention span, and that can make the system feel a bit more robotic and less real. Next, another point that I think models will continue to improve on is integrating real-world knowledge. So one of the big problems with large language models is that they have a tendency to hallucinate and produce false statements, and they tend to do that very confidently, just as confidently as they produce true statements. And that's a real problem if you're looking for a system that's like reliable and to perform, critical tasks. So allowing models to access real-world knowledge and real verified databases could result in more reliable outputs. For example, a huge field of study right now is information retrieval and search augmented models. So one of these would be Bing Chat, which is based on GPT-4. And finally, the last point I want to touch on is computational efficiency. So large language models like ChatGPT that have these, mind-blowing performances are also super, super computationally expensive. Like they wouldn't fit on your phone, and instead they rely on this kind of cloud infrastructure, which can result in kind of concerns relating to response times and privacy of users' data and what they are inputting into the model. And so one example of a way that researchers are combating this is by training smaller models for longer. So, for example, specific example of a couple of models doing this are Llama and Llama 2. And these two models train smaller models on larger data sets for longer time, and it results in a model that performs just as well as these big models, but with significantly cheaper inference because they are smaller. And these are by no means the only paths forward with developing conversational and language modeling technologies. And in fact, there's definitely too many for me to discuss here, but the future of dialogue systems is very bright. And I think there's a lot of promising research being conducted across many great institutions right now. And that pretty much concludes my talk. So if there are any questions, I would be happy to answer them now.
Amazing. Thank you so much, Julia. All right, I have some questions from the Q&A here, and I can also supplement with my own questions. First of all, thank you so much. Those demos were incredible. That was such an interesting talk, and I think you did such a wonderful job of sort of summarizing that history. Like that was really good. Thank you. Yeah, absolutely. So the first question you have is, can you recommend any resources for a viewer, say, who wants to create their own chatbot?
I think if you want to create your own chatbot, I think Hugging Face so I think Python is generally the way to go with doing AI and specifically NLP these days, particularly if you're not if you're looking at getting involved at like a very high level. And within Python, there's this package called Hugging Face that has a lot of pre-built models that, out of the box will work. They're pre-trained, so they're already pretty effective. And some of them are big enough to work like with few-shot prompts. You don't need to worry about having the resources to train a model from scratch. And yeah, so I would recommend looking into Hugging Face. And I'm sure there are some good tutorials, although I can't think of any off the top of my head.
Fair enough. Let's see, another question we have is, how can we reduce the size of existing big architecture? This might be a hard question.
Yeah, so I think so my last point there is about these llama models, which are gaining popularity right now, or maybe they've already gained their popularity. They're pretty big in the NLP space because they essentially show that with much smaller models, you're able to get comparable models or comparable performance to something like GPT-3 with much fewer parameters just by training the system longer. And so there's a lot more expense upfront in training the model because they have to train for longer, but ultimately the cost of inference when like a user is using the model is a lot lower. And so that's one way that people are using to decrease the cost of these models.
Yeah, fair. I'm always curious too, since this is new to me, what the sort of computational bottlenecks look like underneath the hood. Like, is there an enormous matrix multiplication, or is like a lot of
a lot of enormous
okay.
I don't know specific numbers except for GPT-3 takes about 350 gigabytes of VRAM to just load the model and run inference, which is why these are like, when you go on, OpenAI's website, you use basically their infrastructure to run these systems. You don't run it locally.
Right. Okay, that makes sense. Yeah.
Our laptops can't handle that.
Yeah, especially not our phones, like you said. Okay.
Yeah,
cool.
definitely not.
Let's see. So Another question we have is, how do industries use large language models? And asks if you could talk about some common use cases.
Yeah, so I think one way that industries, well, I think right now there's a lot of really exciting new use cases for these models because the abilities of them has like grown so much just over the past couple of years. And one example, a startup that I was working at previously was using language models to handle like call automation with like health insurance companies to, you know, cut down on the awful wait times that it takes to like just get any information out of an insurance company. And so, yeah, I think there's a lot of use cases for these large language models in industry. I personally work at Samsung working on large language models for their mobile devices and, you know, systems of devices and so on. But yeah, I think
Yeah,
that's
absolutely.
about it. I can't get into
Great
specifics, unfortunately,
examples.
but yeah.
No, those are great use cases. Let's see. So Shay asks, and oh, of course, we have an ethics question. So Shay says, I tossed those questions into Google Bard. I'm guessing the questions about the childhood experience and the time flying like an arrow and all that. And Google Bard is not considering itself human, which I find comforting. What do you think about how ethics play a part in the conversation in AI or AI as a whole? And just a preface, I think that this could be like this could be a semester long topic, but go for it.
Yeah, so this is something that also happens with ChatGPT is that it'll often, even in, I think in the last question, when I was asking it which question was the most difficult, it emphasized that, hey, I'm an AI language model, even though my initial prompt said like, pretend to be human and answer these questions. And so that's something that a lot of these really large language models do, is that they really emphasize, they have these kind of blocks set in place so that the model, even though this isn't a part of its training data, presumably, it'll say pretty frequently like, hey, I'm an AI language model, and so this, I can't answer this question, or this question doesn't apply to me very well, or whatever. And I think there's a lot of ethical questions with large, with, you know, this emerging language modeling technology across like a variety of different fields, like in particular, maybe a pretty topical one right now is with respect to creating art and like writing for like screenplays or whatever. Like these models do a pretty good job of like making a painting based on like a user's description, or writing a dialogue or a script based on like some general outline or plot. And I think particularly today, I think it makes sense to have restrictions on AI being used for these kind of purposes, particularly as, you know, people are needing jobs to survive out here. Like, I think it makes sense to restrict the commercial use of AI.
Yeah, absolutely. No, that's a really good point. Yeah, it's exactly what you said. So many artists will have something that's in their style, then, you know, produced very, very easily.
Yeah.
Yeah.
And it's their data that's been used to create such an impressive model. It's like their artwork as a community has been collectively used to build this model without their consent. And so I think it makes sense to place restrictions on that.
Yeah, the consent for your sort of data being used in that way. It's so
Definitely.
interesting. Let's see.
Yeah.
So, this anonymous attendee had the same question that I did. So there are some recent reports that ChatGPT's accuracy has sort of decreased recently. This person says for mathematical
Yeah.
computations, which, so what do you think about that?
Yeah. So I think it's kind of makes me think of like these Jabberwocky and Cleverbot cases where the model relies on this database that's growing based on user responses. And users often have like pretty, questionable, like people aren't really, putting their best foot forward when they talk to these language models. And as a result, the data that the model ends up like, reinforcing on can be low quality, and the quality of data is definitely a huge factor in model performance. So I think there is a way to learn from user input, but I think it requires um, a lot of diligence with respect to like filtering and pre-processing and making sure that you don't include kind of questionable user responses, because there's certainly a lot of those.
Yeah, yeah, absolutely. And right, that could contribute to, I think you hilariously said something like ChatGPT hallucinating or whatever with its
Yeah,
uh,
yeah. So that's, um, I mean, that is, I think, one of the major issues with ChatGPT right now is, and like these other large models, is that you can ask it a question and sometimes it'll get it right and sometimes it'll get it wrong, but very confidently. And I think that is um, a, a bit scary if people are using it for, more, I don't know, important tasks.
yeah.
I think certainly there should be guide rails put on these systems if you're planning to use them for your own purposes, or just like to be aware that these models can output questionable responses, even with high confidence.
Yeah, absolutely. Let's see. So, one viewer asks, will older language models be given up now that new techniques like transformers are, I guess, popular?
I think there's definitely a place for um, older architectures, because transformer-based models tend to be just unwieldy, like very huge, very computationally expensive. And for something like an on-device like AI, you can't really afford to be, querying something like ChatGPT level, or yeah, it just doesn't make sense to use these large models for every application. I think a lot of applications are still solvable with lighter weight models.
Yeah, reasonable. I guess this leads into this next question. One person asks if there are large language models that are updated with new data, and they mentioned that ChatGPT, the knowledge base ends in 2021 or something like that.
Are there, sorry, could you repeat the question?
Yeah,
I
yeah,
didn't.
sorry, I don't think I phrased it very well. So is there an LLM with data that's newer than that of 2021?
Definitely. There are, I mean, as we talked about before, these models are getting updated with user input, and that can impact, the knowledge that the model has. And there are models that have been released this year or past year, like the llama models. I think those are probably using a lot more recent data than just 2021, although I'm not sure exactly what repositories they use or what websites they crawl through their data sets. Um, yeah, I think most of these models are being updated with new data as it comes in.
Yeah, that makes sense. I was also curious, so when you had that timeline before, you talked about this ice age where there was this sort of 10-year gap or something after Eliza and Perry, where no popular models were sort of coming out. Do you have a sense of, or do people have a sense of like why that is? What happened in those 10 years? Or is it just, I don't know, happenstance?
So, I mean, it happened kind of, it tends to happen periodically. We might be coming up on one now. There's like a huge development in AI, and then there's kind of like a cool period where there's no really major developments for a while. And I think in around like the 1970s or maybe the 80s is when there wasn't really a lot of new technology being developed with respect to these dialogue systems and language modeling.
Yeah, it's always so interesting, those kind of natural patterns that arise. Okay, we have 2 minutes, and we'll accordingly maybe answer a couple more questions. And then otherwise, Julia has generously offered to answer questions in the chat that haven't been addressed, that are remaining in the Q&A. And of course, we thank her for her time. But let's at least use our 2 minutes. One person asks, are there any models that actually write music rather than sort of art or text?
Right, what?
Music as opposed to sort of, yeah.
Yeah, so I've certainly seen, I don't have like firsthand experience with these models, but there have been like kind of style transfers with music where there are models out there that can take music or a song from one artist and transfer it to a different artist's style and make it sound like it was by a different artist, or a different singer is singing the vocals. And there's a lot of those like on YouTube, although I don't have personal experience doing anything audio related. I'm like purely text. So I don't even really know what the names of these models are, but I've seen the work of them floating around the internet. So I think they're out there, but yeah.
Yeah, it's incredible. I mean, the possibilities. Okay, so for our last question, I think this one that just came in is perfect. So if we think about the progression in these conversational agents from the 1960s to today, what do you believe are the current trends, and what will that progression look like in the future, in your opinion?
Yeah, so I think the thing that I am most interested in and that I think will make the biggest difference in the performance of like the publicly available language or chatbots or conversational AI that we're using is information retrieval. So like having these verified databases of like factual knowledge that language models can retrieve information from, so that they're not spitting out, total nonsense if you ask it a factual question. And I think that is one of the more exciting areas of research right now. That's certainly getting a lot of attention in the NLP space.
Yeah, wonderful. Okay, well, thank you again, Julia, for sharing your expertise. It was truly a really interesting talk with the demos that were just, I don't know, fascinating to watch from, Eliza to ChatGPT now. And like I said, Julia will be able to answer additional questions from the Q&A in the chat.